There are two key factors affecting stability on a counterbalance forklift truck when it's in the unladen condition. The first is the lower the centre of gravity the better. The second is how the steer axle is allowed to articulate to give four-wheel contact on the floor at all times. If I take this diagram here to show how low the centre of gravity is on the Jungheinrich machine, because the shorter chassis and the counterweight that throws the weight forward, compared to another machine where it's a longer chassis with a narrow counterweight throwing the centre of gravity very high. Here I've got a model that will replicate this with a pivoting steer axle and a centre of gravity. And by putting it on the tilt bed test, I'll take it to a point of tip, bearing in mind this is in the unladen condition, and the truck will begin to tip at that point there. If I mark this off on the wall and then simply improve the stability by changing the pivot point now to a higher position by removing the bottom pin, the pendulum axle now swings. If I carry out the same test, you'll see that it goes far beyond where it was originally, and carry on taking it to a point where it will fall. You can see there how much the stability is improved. What I'll now do is lower the centre of gravity on the model, so we have a high pivot point and a low centre of gravity. Carrying out exactly the same test, you'll see now we go beyond the first point, beyond the second point, and carry on going to a point of tip, which is in that position there. And by marking off on the wall, you will see exactly how much it is improved by lowering the centre of gravity of the truck and raising the pivot point. So in conclusion, there you have two key factors that makes the Jungheinrich machine more stable in an unladen condition.